exponential equations. These will be equations where x is up in the exponent position and how we can solve for what that is. We will have two different methods. The first method is where we are going to equate exponents on two sides of the equation. The goal in doing this, the first step, is to get the bases to be the same. The base is that big number at the bottom that has the exponent. We want to write our bases as being the same number. And then if the bases are the same number, the exponents must be the same number. Because an equals means everything on one side should be matching the other side. So if the bases match, then the exponents should match. So in this equation, on the left-hand side, what is the base? 4. On the right-hand side, 8. They are not the same. So our goal is to write them in a way so they will be the same. And we write them by putting them as powers of the same number. So what number are 4 and 8 both a power of? 2. So we can write a 4 as 2 squared, and that 3x is still just going to hang out. And we can write the 8 as 2 cubed. And the x plus 1 hangs out. So we're rewriting the 4 and the 8 so that they both have a base of 2. Then if the bases are the same, the exponents should be the same, because 2 to the 5th is 2 to the 5th. It's not 2 to the 3rd. So if the bases are the same, then the exponents should be the same. So for our next step, we can now ignore the bases, since we got those to match, and just concentrate on getting the exponents to match. We do need to remember here our property, though, for power to a power. What do we do with power to a power? Multiply them. So on the left-hand side, that 2 and 3x will become 6x. And on the right-hand side, we need to be careful to distribute that 3. So 3x plus 3.
Is it like 2 to the 6x?
We get to ignore the bases at this point, so we don't have to write the 2's anymore. Since we already got the bases to match, now we can just worry about making the exponents match. Yep. And then what did I do to solve this equation?
Minus 3x.
Subtract 3x from both sides. And then divide by 3, and we get x is 1. And we can always check our answer in any algebra equation problem by plugging it back into the original problem. So if I plug that back into the original problem, I would have 4 to the 3rd, 3 times 1, is 8 to the 1 plus 1, or 8 squared. And we can check those on our calculator and confirm that they are the same. 4 to the 3rd and 8 squared are both 64. So this does work. Now, you don't have to check your answer. It's just always kind of a good idea to know if you're turning in right or wrong answers. Questions? The base on the left is 2. On the right is 32. So they are not the same. What base can we use to make them the same? 2. So we can just let 2 be 2, or write it as 2 to the 1st. And 32 is 2 to what power? 2 to the 5th. So we're rewriting that 32 as 2 to the 5th, so that both sides now have the same base. And if both sides have a base of 2, then the exponent should also be the same. So 4x should be equal to, distribute that 5x minus 5. Then we just have a linear equation to work with. Subtract the 5x. Divide by the negative 1. And we get x is 5. We can confirm that works by plugging it back into the original problem, which would make it 2 to the power of 20 is equal to 32 to the power of 4. And I don't know what those are. I could plug them in my calculator. I'm actually not sure if it'll even work. Those are huge, so it might give you an overload on your calculator. I don't know. But that would be how we would check our answer to confirm it. Questions? Go ahead and try this problem, and then we will discuss it. How can I write 9 and 81 with the same base?
9.
9 or
9 squared. 3 squared.
3. There are two different ways to solve this problem. Both are completely correct, and both will give you a correct answer if you don't make any other mistakes in the problem. So I'll show both, and it's just a preference thing. It's whatever you see first. So some people will notice that we can write an 81 as 9 squared and leave the other side as 9. Then our bases are now the same, so we can ignore them and set equal the exponents, distributing that 2, making 6x minus 4. We can then subtract 6x from both sides, giving negative 4x is negative 4, and x is 1. Or some people may think of bases of 3 instead and change the 9 into a 3 squared and change the 81 into a 3 to the 4th. That totally works too. So then we would say 4x is equal to 12x minus 8 and go from there, and you'll get exactly the same answer. So it doesn't matter what you make the bases as long as you make them to be the same. And then once they are the same, you can ignore them and set the exponents equal. Questions? That method is really nice when it works, but it doesn't always work because we can't write everything as bases of the same number. So we need another method when it doesn't work out. And the way we undo exponentials, we've learned, is with logarithms. So when we cannot make the bases to be the same, we're going to solve using logarithms. Our first step, and this is really important, is that you get the exponential alone. We can't have anything multiplied, anything added or subtracted on the side with the exponential. It's really important. A lot of students will forget about that in the homework. So make sure the exponential is totally alone, nothing multiplied, added, or subtracted. Then we will take the log of both sides. We can take any type of log we want. It will be most helpful to take either a common log, which is a log of base 10, or a natural log, which is a log of base e, because our calculators do those. But you could do any log you wanted. And then we will solve for x by applying some log properties. So first step is get the exponential part alone. 2 to the x is all alone. There's nothing multiplied, added, or subtracted over there, so we're good to go. So the second step is to take a logarithm, either the log base 10 or the log base e of both sides. And it doesn't matter. Both will always work. I typically take the natural log because writing ln is quicker than writing log, but it doesn't matter. We can do whatever we want to an equation as long as we do it to both sides. So we're going to take the natural log of both sides, just writing ln in front. Then to solve for the x, we can't solve for it while it's up in that exponents position, but we learned a property before break, so we'll see if anybody can remember here, about what we do with an exponent. We bring it to the front. So one of our properties was that exponents inside of a log can drop down to the front and become a multiplication problem. So it is now x times the ln of 2 is equal to the ln of 7. And how do I undo multiplication? Division. So I can divide both sides by the ln of 2. When you do this on your calculator, when you press your ln button, it will automatically open up parentheses. So you need to make sure you close them after typing in that 7. And then divide by the ln of 2. And that gives us right about 2.8.
down to 1 decimal?
1 decimal's fine. More's fine too. I won't be picky. If the directions say to do something, do what they say.
Wait, so the only thing we have to do with our calculator is x equals ln of 7 over ln of 2.
Yep. Yep, in the calculator we type in ln of 7 divided by ln of 2. So that gives us 2.8, and we can check our answer again if we plug it back into that equation. 2 to the power of 2.8 should be reasonably close to 7. We did some rounding, so it's not going to be perfect, but it should be pretty close to 7. Questions? The first thing we need to do is get the exponential part alone. So we just have a base with an exponent. So in this problem, my first step is subtracting 4 from both sides. So now on the left-hand side, I have just a base with an exponent. Over on the right-hand side, just a number. It does not matter whether you take the common log or the natural log. They will both always work. But sometimes one may be easier. And that is the case here. What's the base of the common log? 10. What's the base in this problem? 10. When we have a base of 10, it will be a little bit easier to take a common log rather than the ln. You will get the right answer either way. Things just clean up a little bit better if we use matching bases. So in this problem, I'm going to do the common log, the log with the base of 10. Now the reason why things clean up a little bit better here is what did we learn happens when our base of our log matches the base of the exponent?
It's just 2x minus 3.
They cancel each other, which leaves just that 2x minus 3. The log base 10 of 10. Just on the one side where the bases are the same, where the 10 matches the 10, then it cancels. On the other side, we're still going to have the log because the 10 doesn't match the 17. But if the base matches the base, they cancel each other out, and we can just then worry about what that exponent was. So if your base is 10, it will be easier to take a common log. What's the base of the natural log? E. So if your base is E, it will be a little bit easier to take a natural log. If your base is anything else, it doesn't matter one way or the other. So now we still need to get x alone here. So how do I get x alone? Add 3. Do not add 3 to the 17. That 17 is trapped inside of that log. So it does not become the log of 20. But 17 is trapped inside of there. We cannot change it. So just add 3 to that side. And then divide the whole thing by 2. So in your calculator, make sure you type it in carefully. Hit your log button. 17, close it, plus 3 equals, and then divide by 2 equals. And what do we get about 2.1?
Yes.
And we can always check that answer by bringing it back to the original problem and plugging it in for x. And we should get something reasonably close to true. It's not going to be perfect every time. Sometimes it'll actually be pretty far from perfect. But it should be reasonably close. Questions? The first thing I always ask myself is that first method possible? Because that was a lot easier than having to take logs at both sides. So is it possible to write 4 and 15 as the same base? No, 15 is not a special power of anything. If it was 4 and 16, we've got something good going there. But 15, not quite. We can't write 15 as any powers. So then we need this second method. First step is to get the exponential part alone. It is. It's just a 4 with a power. So then our next step is to take some sort of a logarithm. And 4 is not a special number for us. 10 and e are special numbers. Anything else, take whichever kind you want. So I like to do the natural log, but it doesn't matter. Just make sure whatever you do on one side, do the same thing on the other. Don't do the natural log on one side and the common log on the other. Then what do? Drop that x down to the front. So now this is x times the ln of 4. So how do I get x alone? Divide by the ln of 4. So on the calculator, we do the ln of 15 divided by the ln of 4, making sure to close parentheses when appropriate. Now you get 1.953, which is very close to being 2, which makes sense if we think back to the original problem, because 4 to the second power would be 16, which is really close to 15. So we would expect our answer to be just a little bit smaller than 2. Question?
I got a 2.38.
Did you close your parentheses after the 15?
No.
Okay. Jake?
What would happen if we had two bases that they could have something in common, but we didn't do that stuff?
It will, you could always do the second method. It's just that the first method is easier when it's possible. Go ahead and give this one a shot. Okay, first thing I would check is it possible to write them with the same base? But 18 is not a power of 5, so I can't do that first method. So then our second method, we take either a log, a common log, or a natural log. So if I take the natural log of each side, I can just write that ln in front. And we'll take that power of x and drop it down. So we end up with a multiplication problem, which we can undo by division. So I get the ln of 18 divided by the ln of 5, which gives me what?
1.796.
So about 1.8, which if we check whether or not that answer makes sense, 5 to the first would give us 5. 5 squared would give us 25, and 18 is between there, so we should expect our answer to be between 1 and 2. Okay. Questions?
Would all answers be like exact on the test? Like, I got 1.75. I don't know how to do that.
1.75 is a little bit off, probably just a typo. But make sure you close parentheses. In this question, it is tempting to begin by trying to equate those bases because 5 and 25 can be written as powers of the same number. But that is not our first step. What is our first step? Got to get rid of the 3. You have to get the base and exponent alone. Anything multiplied, added, or subtracted needs to be removed. Now 22 cannot be written as a power of 5. So now we need to do logarithms. 5 is not a special number, so you can do the common log or the natural log. So I'll just write an ln in front of both sides. Then we're going to bring down that power of x plus 2. That whole power of x plus 2, which is all a group together. So we need to use grouping symbols when we bring it down front. So x plus 2 grouped in parentheses times the ln of 5 equals the ln of 22. What do I do to solve that? Divide by the ln of 5 on both sides. You could distribute that ln of 5. It would not be wrong, but it would be messier. And then finally, to get x alone, we would subtract 2, not from the 22 or 5, but from that whole thing. So we're going to type in the fraction like we did on the last question, and then subtract 2 from that. And that gives me about negative 0.08. Which, if we want to think about whether or not this answer makes sense, that's pretty close to just being 0. So if I would just plug a 0 in for x in the original problem, that would give me 5 squared, which is 25, plus 3 is 28. That is reasonably close to 25. Okay. That rounding error will create some problems.
What about negative 0.1?
Yeah, if you rounded to negative 0.1, that's fine. I'm not going to be picky on the rounding. What's our first step on this one? Subtract the 8. Get the base and exponent part alone. Then we cannot write 10 and 27 as the same bases, so we need to take some sort of a logarithm. What sort of a logarithm should we take? The common log. We have a base of 10. It's not wrong to take the ln. It just doesn't clean up quite as nice. You'll still get the right answer. It'll just be a little bit messier to type it into your calculator. Whereas if we take the common log, which is the base of 10, we get something nice that happens over there. What happens? Cancels. Log base 10 of 10 goes away to leave us with just that 5x plus 4. You don't have to write the base of 10 when you write log base 10. That's kind of like putting that little 2 on the square root. You don't have to do it, but it's not wrong to do it. I still need to get x alone. How do I do that? Subtract 4 and then divide by 5. Now remember, we don't subtract the 4 from the 27. It doesn't become a 23. It just tags along the end there. So when you type it in your calculator, make sure you close your parentheses after that 27. So the log of 27, close it, minus 4 equals, and then divide that by 5. And we get about negative a half. Okay. So in this question, you could do the common log or natural log. It doesn't matter which, but it was a little bit easier to do the common log because stuff cancels. If you have a base of e in your problems, and you will on your homework, it will be a little bit easier to take an ln. Because if I have ln of e to something, that ln of e cancels. And so then we would just be left with whatever that something is. Okay. So if your base is 10, do a common. If your base is e, do a natural. Anything else, do whatever you want. Your homework is from 8-6. The note there says for the first 5 problems, you can equate the exponents. That means for the first 5 problems, you can do the first method we learned, like the first 3 examples of the notes.